Assalamu alaikum. Hello everyone. Welcome to being here. Before beginning, let's for a while to introduce myself. I am Adil Ahmed Mahady and I am currently a student of Department of Computer Science and Engineering, Comilla University. At first, I thanks to our honorable teacher, Faisal bin Abdul Aziz sir, for giving me a floor to explore myself. Today's my presentation topic is clock RS flip-flop and JK flip-flop. Let's explore it. Let's know about flip-flops. Flip-flops are basic digital memory circuits used in sequential logic. They can store one bit of data and are triggered by a clock signal. Flip-flops are essential components in digital systems like computers, registers, and memory units. Here, two pictures are given. One of them is clocked RS flip-flop and another one is JK flip-flop. Let's know about the characteristics of flip-flops. A flip-flop is a vestible multiplicator. It has two stable states, 0 and 1. Output changes based on the input signal and clock. It uses feedback to maintain state. It operates with clocked or unclocked control. Let's know about the clocked RS flip-flop. RS stands for reset and set. Clocked RS flip-flop activates only on clock signal. It contains as inputs S for set, R that means reset, and clock. It contains as output Q and Q prime. Here Q prime is the complement of Q. It typically built using NAND or NOR gates. Let's know the working mechanism of clocked RS flip-flop. It has three inputs, state, set S, reset R, and clock. When clock is high, then when S equal 1 and R equal 0, the output is set, that means Q equal 1. When S equals 0 and R equal 1, the output is reset, then Q equal to 0. When S or R both is equal to 0, then the output is no change. When S equal to 1 and R equal to 1 also, then it state invalid states. Here the truth table of clock RS flip-flop. When clock is always high and S equal to 0, R equal to 0, then the next state is Q. When S equal to 0 and R equal to 1, then the next state is 0. When S equal to 1 and R equal to 0, then the next state is 1. When both of S and R equal to 1, then the next state is invalid. Here the logic diagram of clocked RS flip-flop. It is the logic diagram of clocked RS flip-flop. Let's know the drawbacks of RS flip-flop, that mean invalid condition issue. The RS flip-flop has an undefined output when both set and reset are 1 while the clock is high. This is known as the invalid or indeterminate state and must be avoided in real circuits. Let's know the practical uses of RS flip-flop. Simple memory storage. It uses in control signals in FMS, that means finite state mechanisms. Rebalancing circuit, it is also uses in simple control logic. Let's explore the JK flip-flop. The JK flip-flop was developed to overcome the invalid state in RS flip-flop. It allows both input to be high without causing ambiguity, using feedback mechanisms to toggle the output instead. Let's know the overview of JK flip-flop. It modified version of RS flip-flop. It solves the problem of invalid state in RS flip-flop. It contains as input J, K, and clock. It contains the outputs Q and Q prime. It is named after JK Q. Let's know the working mechanism of JK flip-flop. Here the inputs are J, K, and clock. When J equal 1 and K equal 0, then the output is set. When J equals 0 and K equal 1, then it stays reset. When J equals 0 and K equals 0, there is no change. When both of J and K equal to 1, toggle the output. The output changes only on the rising or falling edge of the clock. Here the truth table of JK flip-flop. When clock is always high, then J equals 0 and K equals 0, the next state is Q. When J equals 0 and K equals 1, the next state is 0. When J equals 1 and K equals 0, the next state is 1. When both of J and K equal to 1, then the next state is toggle. That is the logic circuit of JK flip-flop. Let's know the race around condition in JK flip-flop. When both of J and K equal to 1 and the clock pulse is too long, the output toggles repeatedly. This unwanted behavior is known as the race around condition. It can cause instability in circuits. Let's know the method to avoid race around. That means using master slave JK flip-flop. Master slave JK flip-flop uses two JK flip-flops in series. The master responds to the clock's leading edge and the slave responds to the trailing edge. This structure eliminates race around by separating input and output transitions. Let's know the difference between RS flip-flop and JK flip-flop. RS flip-flop has an invalid condition that JK doesn't. JK allows toggling that RS can. JK flip-flop is more versatile and reliable in sequential circuits. Let's know the applications of JK and RS flip-flops in digital electronics. JK flip-flop is used in counters, registers, and memory units. RS flip-flop is used in control logic, simple memory. Both are fundamental building blocks in digital design. Thank you everyone for listening me. Thank you.